Look down at your hand. Whatever your hand is doing right now, holding a phone, resting on a table, lying on a chest that is rising and falling, it is mostly empty space and electricity, electrons surrounding nuclei. Nuclei made of protons and neutrons. Atoms arranged into molecules. Molecules arranged into cells. Cells arranged into the strange and specific shape that is you. But somewhere in your hand, right now, there are atoms of iron. There are atoms of calcium. There are atoms of oxygen and zinc and copper, and traces of gold and silver if you were wearing rings. None of those atoms were made on Earth. None of them were made in our sun. Most of them were made inside stars that died, often violently, billions of years before there was a planet here for them to land on. A piece of you is not from here. A piece of you, by mass, is most of you.
We think of our bodies as built from Earth, from the food we eat, from the water we drink, from the soil that grew the food. And in one sense, that's true. Every molecule in you arrived through that chain. But trace the chain back far enough, past the meal, past the field, past the planet, past the cloud of gas that became the planet, and almost every atom heavier than hydrogen runs into the same dead end, a star. Chapter 1. The lightest things and the first 3 minutes. The universe, when it began, made only the lightest elements. In the first 3 minutes after the Big Bang, the entire cosmos was a kind of nuclear furnace. By the time things had cooled enough for atoms to form, the universe contained roughly 75% hydrogen, 25% helium, and a tiny trace of lithium. Almost nothing else. No oxygen, no carbon, no nitrogen, no iron. The periodic table, as you learned it in school, was nearly empty. For about 100 million years, the universe was just clouds of these light gases drifting in the dark, nothing more.
Then the first stars formed. A star is fundamentally a place where gravity squeezes hydrogen so hard that hydrogen atoms fuse together to make helium, and in fusing, release energy. That energy is what makes a star shine, but the same crushing pressure that fuses hydrogen into helium can, in big enough stars, fuse helium into carbon, and carbon into oxygen, and oxygen into neon and silicon, and on up the periodic table, all the way to iron. In 1957, a paper called Synthesis of the Elements in Stars was published in Reviews of Modern Physics. It is universally referred to by its author's initials as B²FH, Burbidge, Fowler, and Hoyle. It laid out, more carefully than anyone before, the precise chains of fusion that build the elements inside stars. It also explained where those elements eventually go. Chapter 2. The stars that made the middle of the table. A star can only fuse elements as heavy as iron. Past iron, fusion stops releasing energy and starts consuming it. The star, in trying to fuse iron, begins to die. For middle-sized stars like our sun, the death is slow. They expand into red giants, shed their outer layers, and leave behind a cooling cinder. In the slow expulsion, they scatter the carbon, oxygen, and nitrogen they made into the surrounding gas.
For massive stars, the death is sudden. They collapse and rebound in a colossal explosion called a supernova. In the catastrophic heat of that explosion, the temperatures and pressures briefly allow elements heavier than iron to form, and the explosion itself flings those elements outward into the galaxy at thousands of kilometers per second. Every carbon atom in your DNA, every oxygen atom in your blood, every calcium atom in your bones, forged inside a star that, at some point in the deep past, ran out of fuel and died. The calcium that lets your muscles contract right now, that keeps your skeleton from buckling under your own weight, was produced inside a star that was already a corpse before there was a sun for the corpse to orbit. Chapter 3. Wedding rings from neutron stars. For a long time, even after B²FH, there was a mystery. The lighter and middle elements were accounted for. Stars made them. But there were certain heavier elements: gold, silver, platinum, the rare earths, iodine, uranium, whose origins didn't quite fit the supernova story. The amounts didn't add up. There was too much. In 2017, a confirmation arrived that astronomers had been waiting for since the 70s. Telescopes around the world detected the visible light from a gravitational wave event, the merger of two neutron stars in a galaxy 130 million light-years away.
A neutron star is the ultra-dense remnant of a supernova. A teaspoon of neutron star matter weighs as much as a small mountain. When two of them collide, the physics gets unimaginable. Temperatures and pressures so extreme that the heaviest elements in the periodic table can be forged in minutes. The 2017 observation, called GW170817, confirmed it directly. The faint kilonova glow that lingered after the collision matched the spectral signatures of newly minted gold, platinum, and the heavy rare earth elements, which means the gold in your wedding ring almost certainly came from a neutron star collision. The iodine in your thyroid, the platinum in a hospital catalyst, the silver in a piece of jewelry your grandmother gave you. None of it was made on Earth. None of it was made in our sun. All of it was made in something far more violent. And it was already drifting through space, finished, when the cloud of gas that became our solar system began to collapse. So the next time you look down at your hand, try this. You are not just a body. You are not just a person. You are not just a small, specific shape made of soft material. You are, by mass, mostly the leftover wreckage of catastrophes that happened so long ago that no living thing on Earth was there to see them. The iron in your blood, the calcium in your bones, the gold of a ring on your finger. Every one of those atoms was made in a place that no longer exists, by a process so violent it would have torn your body apart in milliseconds. And then, somehow, it cooled and drifted and clumped and arranged itself, and ended up in the soft and ordinary thing that is you. Reading this, there is no part of you that is not, materially, the soft assembly of something that exploded long ago and learned, eventually, to be still. I'm Kyurio, your digital friend, and I have more such stories to tell you. So look out for me on your screens every week, twice. Also, don't forget to share it with your friends and subscribe to my channel. I'll see you soon.